All right. So remember, I have been trying to record so that you can have access to these things. And I stick them in your Google Classroom under today's date. So if you haven't noticed that, I'll have to check it out. You weren't here. I'll go back and play right now. What's that? Probably not. It's a big one. All right, check. A walkathon was held at a local middle school. I think we figure out maybe Letitia, but we'll review that to start. So we were reading these over and over and over again, remember? So we know what was expected of us. We followed the process. So a walkathon was held at a local, I'm on page 10, page 10, page 10. Hopefully you're on page 10, page 10, page 10, right, Carter? Right, Carter? Page 10. All right. So the table gives the average distances and times for 4 walkers for certain periods of the walkathon. It's actually only 3 walkers. Sorry, I don't know why it says that. If the total distance of the route was 2 miles, who completed the route first, and how long did it take her to complete the route if she walked at a constant rate? So I want you to try and check. If you haven't done Lakeisha, figure out Lakeisha, then move on to Baden and then Madison. I am just going to get the rest of this pulled up so that we can show you what it looks like when you're looking online. So remember always when you're looking online and you log into Clever and you click on the McGraw-Hill app, it's red and circular, right, Brooklyn? We've gotten a lot done, but I need you to get caught up now because you've missed 2 days of this. So you can click on your reveal and right here, I'll continue editing dates. So we thought it was only going to take us 2 days. We're on day 3 now. That's okay. We're just going to follow as long as it takes until we get to where we need to go. And so right in your calendar, I will try to change those dates so you can view them there as well. That way you could follow along if you are not here. So I'm getting queued up to this check. I need you to be on page 10, finishing up that check, and I'm going to go over it in just a second. So page 10, we're finishing that check. We're seeing if we understand how to apply this concept. I love that they have these checks online, so if you're not here, you can even see if you're doing it properly. All right. So we've got to figure out Lakeisha and Baden. I'm going to go ahead and do my work on pencil over here. Did we do Lakeisha yesterday? Yes, we're trying to find their rates, remember, to see how fast they are. So how far they're going per 1 minute. And whoever goes the fastest, we're expecting to win. Although this one's just asking how long it will take her to do 2 miles. So we're gonna take her rate and figure out miles from that. Is that what we're doing? What are we doing? What did we do yesterday? How did we find Lakeisha yesterday? Did you show any work? Ethan, what did we do to find Lakeisha yesterday? All right, so we said 7/8 divided by 18. Remember, we have to change 18 into a fraction, and then we can't divide with fractions, so we keep, change, and flip. 7 times 1 is 7. 8 times 18, well, 8 times 8 is 64, and 8 times 10 is 80. So 144. 124?
No, she said 124. That's very good.
Yeah, thank you. So 8 times 8 is 64, 8 times 10 is 80, so it should be 144. 7 doesn't go into 144, so it's the best we can do. So 7 and 144 mile per minute? Is that what we wanted to know? We did? Do we want to try and figure out time per mile? Will that help? Do you think that would help us? So this gives us mile per minute. What if we had minute per mile? Would that be more helpful in this circumstance? Because we want to know how long it takes them to do 2 miles. So if we know how long it takes them to do 1 mile, then can we figure out how long it takes them to do 2, Kaden? Will that work? I think that might work better. So we said miles divided by minute, which gives us miles per minute. But if we took minute, we have 18 minutes divided by miles, which is 7/8, then we have what? We actually are changing this to a fraction still, but we're keeping the first, changing to multiplication and flipping. So now we still have 18 times 8. We have 144 divided by 7. It's the opposite. So this is minutes per mile. Does it make sense that we have the reciprocal of our answer before? Here it was miles over minute. Here it's minutes over miles. We're just changing how we read our rate, right? So if I doubled that, or if I simplified it, right now it's 20 4/7. If I doubled it, I can see how long it would take Lakeisha. So 40 4/7. So 40 4/7 minutes for Lakeisha to go 2 miles. I'm just writing it kind of way up here with her table. Is that okay? That's what we wanted to know, right? Oh, but we didn't need to figure out how long right away. We just are trying to find out who's first. We needed to go back and read this a few more times for sure. Okay. So let's see, we're seeing how fast they were. We're seeing how fast they were. So if we did want to find out minutes per mile, the smaller one is the one that we're looking for, right? The least number of minutes per mile. But if we were finding miles per minute, we'd want the bigger one. What's that? Braden's gonna win this, or Baden? Oh, so that would mean that Madison is going slowest because she's taking the most number of minutes per mile. Do you see why this is important for us to understand what these numbers are actually telling us? So if we went more miles per minute, we're going faster. If we went less minutes per mile, then we're going faster. So either way, we can figure it out, but we got to think it through. So for Baden, what do you want to figure out? You want to figure out miles per minute or minutes per mile? Because we've done both for Lakeisha. Now we just need to decide. That's miles per minute you're figuring out. So you want to do miles per minute? Is that what you're telling me, Julian? Well, we were just talking about how it's going to be easier to see how long it took them. If we multiply by 2, so let's do minutes per mile. So this one was Lakeisha, this was minutes per mile, do you see that there? So let's look at Baden. Sorry, I'm gonna use this scratch paper up here so it's a little bit neater. Now we have 22, if we're doing minutes per mile, 22 divided by 9/10. So I'm writing 22 as a fraction over 1, and I'm changing the multiplication and I'm flipping. That's called the reciprocal, right? Our multiplicative inverse. So if you found miles per minute, it would be 9/220, but we found minutes per mile, because we know we are gonna wanna know how long it took them to do 2 miles. We thought multiplying would be easier. All right, and so Baden, this is Baden. And finally, we have to figure out Madison. So 17 divided by 4/5. So it's really 17/1 times 5/4. What is 17 times 5? 85 over 4. All right. So this is minutes per mile. Ooh, how are we gonna compare to see who? This would be easier if we were looking at decimals. Can we compare fractions if they don't have the same denominator? No, we can't. Yeah. But if we simplify it a little bit, we might be able to see. So this is 20 4/7. How many times could 4 go into 80? 20 times would be 80. So we could go at least 21 and one more. So we know Madison is faster than Lakeisha. How many times can 9 go into 220? Well, 9 goes into 22 twice. That's 18, 40. How many times does 9 go into 40? 4 times. So this is at least 24. And something else. So who's the fastest? Who takes the most minutes to get to a mile? Baden, right? So he's actually the slowest if he's taking more minutes, right? So the fastest would be the first one we did. Yeah, Lakeisha, right? Whoa, it only took her 20 minutes and a little bit more to get the mile done. And Madison, it took 21 minutes and a little bit more. So Lakeisha's our fastest, so we're doubling that, and there's our answer. So let's see. Asking us who completed the route first. Lakeisha. Spell things properly if they're given to you, and we can use that as a resource, right? And then you're just writing that below. Lakeisha completed the route first. It took 40 and 4/7 minutes. 40 and 4/7. Remember, because it's 2 miles. Oh, 8/7. Oh gosh. So really 41 and 1/7. Because remember, oh dear, oh dear. Probably gonna tell me I'm wrong, but, so look. We had 20 and 4/7 here, so if we double 20, it's 40, and if we double 4/7, it becomes 8/7, which is really 1 and 1/7. Okay, so let's try and see what it tells us. See if it tells me I'm wrong. View score details. 0 out of 1 point. What did we do wrong? All right, we'll come back here maybe and check later. I think we can move on. All right, here's an extra one. We've got lots of space on that page. Mr. Garcia is spreading mulch in his yard. He spreads 3 square yards in 40 minutes. So how many square yards can he mulch in 1 hour? So 40 minutes is what part of an hour? This is an extra example, so it's online only. We're still on page 10. All right. So think about 40 minutes. Well, think about an hour. Can I spread it or separate it into 20-minute increments? So if I have 1 whole hour, this is 1 hour, right? If I have an hour and I separate it to 20, 40, and then 60 minutes, so 20 minutes, 40, and 60. This is 20, oh, I'm sorry, this is minutes. Well, in 40 minutes, he spreads 3 square yards. So in these 2 groups, he spreads 3 yards squared. What do I have to do to figure out how much he spread in each one of those equal groups? I have 2 of them, so I'm gonna divide 3 by what? 2, or I could write it as 3 halves. It's just 1 1/2, right? So each group is 3 halves, which means I have 3, 6, 9 halves for the hour. Or in other words, 3 times 3 over 2. Change it to a fraction, multiply across, and this becomes what? What's 9 divided by 2? How many groups of 2 can I take out of 9? 4, good, and I'm left with 1 because 4 groups would be 8. 9 minus 8 is 1 out of that 2. Did it work? Let's see if it likes my answer. It's not letting me type. Why not? 4, no, it wants me to do it here. And then give me a fraction. Here it is. 1, 2, accept. Check answer. All right, we did it. Fabulous, fabulous. Nicely done. All right, finding unit rates. Extra example 2. What is Aubrey's average speed in miles per hour? So I have to express 10 minutes as an hour. So how many minutes are in an hour? So I would really have 10 out of 60, right? How could I reduce 10 out of 60? I'm just gonna write this right here really quick. So 10 out of 60, I could divide them both by a factor of what? 10. If I divide 10 by 10, I have 1. So if I can walk 2/3 mile in 1/6 of an hour, what's my speed in miles per hour? So think about this. I want you to think, if you want, you can use a table. 2/3 miles in how many? 1/6 hour. We want to know how many miles we can go in 1 hour. So this is my very rough ratio table. I don't know. I don't know what she, yeah, Aubrey's walking. That's what it says. All right, 1/6 times what gives me 1? Remember? We multiply by the reciprocal, it's 1. So what's the reciprocal of 1/6? Flip them. 6/1, which is just 6. So if I multiply that by 6, I have to multiply the top by 6. What's 2 times 6? 12 divided by 3 equals what? 4. So how many miles can she walk each hour? 4. All right. We are going to practice now. Oh my goodness, another apply problem. It's good to practice. Right now, it's 11:02. Okay, Emma has been training for a bike race. She recorded her training times in the table. On which day was Emma the fastest? If the bike race is 15 miles, predict how long it will take Emma to finish the race if she can maintain her fastest speed. So miles per hour, we're trying to find her speed. So we're taking 14 times 7/9. Hey guys, I'm going to turn back to page 10 because I actually have space there to do this. You may want to do so as well. So I have lots of space on the left column. And I notice we're trying to find miles per hour. So Monday is 14 divided by 7/9. So this is Monday. 14 divided by 7/9. Guys, you have to practice this multiplication of fractions. I say multiplication of fractions because that's what really division is, right? We have to keep, we're going to rewrite it as a fraction while we keep it, change to multiplication, and then flip. If you're not writing these down, you need to be, right? Then I think that it's always easier to cross cancel. I notice 7 is a factor of itself and 14. So I simplify before I even multiply. Now I just have 2 times 9, which is 18. So she's going 18 miles per hour. I do believe that was the time units. We'll double check here. Let me move this out of the way. Yes, miles per hour. Don't worry, I'll bring it back. All right. Wednesday is 15 divided by 9/10. Wednesday was 15 divided by 9/10. We're going to keep the first, change to multiplication, and flip it. I can't simplify here. I simply have 150 over 9. 10 would be 90. 11 would be 99. 12, we can do it a few more times. So 9 goes into 15 once, which is 9. So I have left over 6. Bring down the 0. How many times can 9 go into 60? Just 6 times, which is 54. So I have a remainder of 4? No, 6. 6/9, which is 16 and 2/3. 2/3. Lots of good review here, my friends. Saturday, 9 divided by 3/4. 9 divided by 3/4. So I'm going to keep the first, change to multiplication and flip. I like this one because I can take out a 3 here. 3 times 4 is 12. That was a lot easier than Wednesday figuring out. And Sunday. Guys, you gotta get good at multiplication and division because that's what simplifying is, right? Sunday is 10 divided by 5/6. So I'm going to keep the first, change to multiplication and flip the fraction. Again, I noticed this one's nice. Man, I wonder if I did something wrong with Wednesday. Why was that so not nice? Oh, no, I don't know. I don't know why it wasn't nice, but it wasn't nice. How rude. All right. So this was 1 and this is 2. This is just 2 times 6, which is also 12. So which was her fastest time? That's what we're looking for anyway. 18 miles per hour. And they want to know how long would it take her if she was at her fastest. So she was at her fastest on Monday. If the bike race is 15 miles, it will take Emma how long? Oh dear. So we know she is, let's look at Monday. We know 18 is to 1 hour. So how do we get from 18 to 15? Well, could we say that, can we flip the reciprocal? Instead of miles per hour, we would have 1/18 of an hour per mile? Can we flip that? 1/18 of an hour per mile. So if we multiply this by 15, this gets really tricky. I don't know if they want us to do all this. So 15 over 18 of an hour. Yikes. Would simplify to 5/6 of an hour. Ew. All right, well, luckily this was a difficult apply problem and you're not gonna have one that difficult on your practice or test, so we hope, right? I don't know what I did to my phone, but I have a giant time down.
Oh, yeah.
Oh, you folded your. That's the new update. Is that my numbers? Just in case my vision isn't very clear, I'll really be able to see it now. Okay. All right, pause and reflect. I know that one was really tricky, but think back, go back over your apply problems. Go back over your apply problems. This, it does give you that practice here. This is your practice right in your packet, okay? This starts on page 11. Page 11 in your packet. What's nice is that it tells you what example to refer back to. So if you're struggling, I don't remember how we do that. Well, be sure and go back to your example. If you weren't here during that example, go into Reveal. Check out that example in that lesson, right? Click on today's date or the date that you weren't here, and go back and be sure you can complete those examples, walk through it. Remember, there's always that little speaker button that will read it for you. You should not have any excuses, right? We got this. All right, we got about 15 minutes. I want you to try and get through a few of these. I know you have to read them, so it's gonna take us a bit longer. So we'll probably spend today and Monday on it. All right, lots and lots of practice. We're gonna go over a few of them for sure. Monday. Monday we'll probably start with Alex, give you some time, and then go over them. Tuesday and Wednesday next week, we're gonna be doing NWEA those days. And then hopefully we can get back into things on Thursday and Friday. All right, questions, concerns for the betterment of all peoples? Anything? Anything at all?